Hi everyone. Okay, we are classifying real numbers. We're doing lesson 1, 2, and the first thing to do is just kind of classify real numbers. And um, so we've got a little bit of vocabulary and definitions to get in this video. Now, real numbers. The set of real numbers. That is like all the fractions, decimals, negatives, positives. It's right now for what we're doing. We're actually going to extend this later on in the course, but let's just say right now it's the big set of numbers before we go into complex numbers. This is the big set of numbers. It's pretty much every number you've ever heard of. And that big set of numbers can be split into rational numbers and irrational numbers. Any number you've ever heard up to this point in your just in your mathematics education so far. Now, a rational number is any number that can be written, and this is a lot of numbers you've heard of, as a fraction. It can be an improper fraction, top heavy, whatever you want to call, but it's like A over B. A and B are integers, which we're going to talk about later. But if I think about all the numbers it would be all terminating decimals. Actually, all repeating decimals. We can figure out a way, if it's a repeating decimal, we can figure out a way to write a fraction. We can find that fraction that would equal that repeating decimal. So obviously all fractions then, any number can be written as a fraction. A fraction can be written as a fraction. And if you think about it, like 3 is equal to 3 over 1. That's a fraction. 3 over 1 is a fraction. So all whole numbers as well. And maybe I should write all whole numbers are a subset of the integers, because integers can be negative and positive, and I put all that in there. So every one of these are going to be rational numbers. They're just a part of the rational numbers, a small part. Now, irrational numbers. Okay, they are real numbers that cannot be written as a fraction. Maybe rewritten might be what I want there, as a fraction. I think it's easier when we're talking about irrational numbers if I take something like the square root of 7. What's going to happen is you're going to get some decimal. You can put it on your calculator a lot. It'll fill your calculator with decimals. It's irrational, and it's square root of any whole number that's not a perfect square would be irrational. Where you get that decimal afterwards, okay, it is a non-terminating, when you change it to a fraction, terminating, non-repeating. So there's not just a bar that you can write over the thing, because the same set of digits repeats all the time. Non-terminating, let's write and non-repeating decimal when you change that. So like square root of 7. Now another common one that you learned in your geometry courses is the number pi, the 3.1415. You know you're not going to get to the end of that. It's not going to end, but there's also not a repeating pattern in it. Okay, another one, if we get into compound interest, there's a number called E, and it's approximately 2.718, but and when you make your 3 decimals like that, or 3 dots like that at the end, you're not saying it's repeating. So square roots of non-perfect squares. Now, if I were to take the square root of, let me do it down here. If I were to take the square root of 9, that equals 3. Now, integers, and so that would be considered a whole number. Sorry. It also would be considered an integer. And so just because the square root's there does not mean necessarily that it's irrational. You gotta know, does it equal a whole number when you're done? So integers. Let's say numbers with no fractional or decimal part. Now, if I were to make a set of numbers, first of all, they can be negative. So it'd be like -5, -4. The numbers are actually going up. It seems like they're going down, but they're actually going up because they're getting less negative all the time. And the less negative you have, the bigger the number. Then 0 is also. So they can be negative, 0, or they can be positive. These, and I'm going to put the brackets here, and so on. These are a way of kind of describing, writing all with the 3 dots here and the 3 dots here. Say we keep going in both directions for the integers. Now whole numbers are a let me just write them like this. Let's say whole numbers are integers that are greater than or equal to 0. So the integers, so from here on, so we have a smallest whole number. That would be 0. 1, 2, 3, 4, 5, and so on. And then things that would be considered integers, like -25 over 5 is equal to -5. So just because it's written as a fraction, it's a rational number, but it's also, more specifically, an integer. I have a square root of 9 is 3 here. So that is an integer. It's also a whole number, because square root of 9 is equal to 3. Anything else about whole numbers? They start at 0. The natural numbers actually start, they're almost like the whole numbers, but it's when you start listing off numbers, you usually don't say 0, 1. You usually start with, when you start counting. So natural numbers are also known as counting numbers. So the only difference between the natural numbers and the whole numbers is the whole number, 0 is a whole number. It is not a natural number. So natural numbers are the whole numbers without 0. Okay, one final thing, just kind of an organizational diagram here. If I talk about while we're doing it, a lot of times instead of writing out those numbers all the time, the set of real numbers, we use a big fancy R. I like to write that. Okay. Set of rational numbers, the letter, since R is in that, Q was chosen by some mathematician along the way to represent the set of rational numbers. Irrational numbers, they do start with I, but I also is the first letter of integers. The set of integers, a lot of times Z is used. And then we use W to represent all whole numbers, and all natural numbers we use N. Okay? So I was about to make this diagram here to kind of organize. Let's say my big box right here that I'm making inside the diagram here is the set of real numbers. I'll just use the letter R, the fancy letter R. Okay, that is the set of real numbers. Now, inside the real numbers, we have you're either a rational number or you're an irrational number. Set of real numbers. That's the only two divisions it can be. All right. Now, inside all those rational numbers, we could have the integers, but that's not the whole integers, whole numbers, natural numbers. That's not the whole part. So I'm going to make a little circle here. The outside circle here is my set of integers. I'll put a Z inside that. And inside the set of integers is the whole numbers. And inside the set of whole numbers is the natural numbers. Okay, so just to kind of get a relationship between those. All right, that's all for this video.